Let's verify that tangent squared minus sine squared is equal to sine squared times tangent squared. All right, now this one we're going to have to work both sides. Let's start with, as we're looking at this, it's like, they're kind of close, except this is subtraction, this is multiplication. What do we do here? I'm going to just take some guesses here. I know I can go to quotient, and I'm going to try to change everything to sines and cosines. So if I use the quotient, I know that tangent squared, psi y cosec tangent is y over x. So this is sine squared x over cosine squared x. I'm not going to change this sine x for the time being. Come over here. This sine x remains the same. But the tangent I'm going to change again. Psi y cosec tangent is y over x. That's sine squared x over cosine squared x. All right, now I can start looking around. What can I possibly do? Well, I could try to factor maybe. Since nothing really cancels, I can make this sine to the fourth. That doesn't do so. Or I could try to give it a common denominator maybe. Since this shares one denominator. You can try a lot of different things. So we could try, let's just try getting a common denominator. Maybe since this is one fraction, technically speaking, this would be one fraction. Let's see if we can make this one fraction have the same denominator. So how would I get this? I just need to multiply top and bottom by cosine squared x. So this here is common denominator is what I'm doing now. And so now that I have a common denominator, these should be able to combine. So I would have sine squared x minus sine squared x cosine squared over cosine squared x. Now all that needs to equal, basically, when I simplify this, sine to the fourth power x over cosine squared x. All right, now we're here. We're thinking, what can I possibly do next? Well, you see all the squareds up here? Oftentimes when you have squareds, we're going to end up using Pythagorean theorem. But to do so, we need to do a GCF first. So if I did a GCF, what's common, what's shared here is sine squared. So if I pull out the sine squared, I'm left with, when you divide this by sine squared, you're left with 1 minus, this sine squared comes out, I'm left with cosine squared here. All this is over cosine squared x. I'm not touching the right side right now. I'm going to leave that. Now let's continue on. 1 minus cosine squared. Let's look at the Pythagorean because I have a 1 and a squared. Here it is. But to make it 1 minus, I would have to subtract the cosine over. That means 1 minus cosine squared, if that was moved over, would equal sine squared. So this equals sine squared right there. So we're going to write this as Pythag because that's our next identity. So we're going to change this right here to sine squared. So now I would have sine squared x times sine squared x, and that would be over cosine squared x. Well, guess what that equals? Sine squared x times sine squared x is sine to the fourth power over cosine squared x. Is that what we had there? It is. We've come up with our answer. This would be verified because we worked both sides and we came to a spot where they're equal to one another. Sine fourth x over cosine x is equal to sine squared times sine squared over cosine squared, and this, when we did the quotient, was equal to tangent squared. So we did verify.